Hello. For today's problem, we're going to be doing top k frequent elements. So you're given an array nums and an integer k, and you want to return the k most frequent elements. You can do this by returning the answer in any order. Okay, so hmm. So for our input, we're given this array of nums with k equals 2, and you want to return 1 and 2 because those occur the most frequently. Same thing with this. We can have it that one occurs most frequently as well. Okay, so my first thought with this one is you could have a hash map that keeps track of the frequency. And with that hash map, you could then loop through the array, adding one for each one, and then I guess figuring have some sort of way to derive the most frequent way from the most frequent elements from the hash map afterward. So hmm. One potential way you could do this is with a heap. So you could convert the hash map into a heap afterward by using the heapify method, and then from there you can then return the most frequent elements by popping the most frequent out of the heap afterward and just return those values. But the problem with that is the heapify method has a will cause the time complexity of this to be O of n log n, because that's the runtime of the heapify method, if I'm not mistaken. Uh, yeah, right. Yeah, runtime is n log n. So another faster way we could do this approach is by using bucket sort. So an idea that we could have is we could have let's say like a bucket of sorts over here, and we want this bucket to be the length of nums, pretty much. That's what we want it to be. And what this bucket can entail is that if you have one, like a 111 222 2233, the frequency of it can be basically, like, let's say like for this example, we noticed that this is repeated 3 times, this is repeated twice, this is repeated once. We can put that at the indexes of it. So like, for example, we have like 0, 1, 2, 3. We can place that since this has happened 3 times, we can put the 1 value in here, and for 2 over here, we can put that over here because it's only occurred twice. And we want this to be the length of nums at the maximum, because you could have a certain scenario where you have 1 1 1 1 1 1, like basically like you can have it occur 6 times. You want that to be able to potentially like be like at the last value in the array over here. So we have 1 2 3 4 5 6 over here. Yeah, so basically you want to initialize this bucket, put the values from the hash map that we were talking about, that we loop through every single time we count it. We put all those values into each corresponding value in the index, and then afterwards with this bucket we can then loop through, starting at the very end and going backward, and basically returning all of the elements after until you reach the k most frequent elements. So we can get started with that now. First, we want to initialize the bucket to be the length of nums. So this for so we'll initialize it using this. The next thing we want to do is we want to loop through every single value in the nums and put it in the hash map. So we'll have a hash map, we'll call it count, let's say. And what we're going to want to do is put everything in there. So we'll do yeah, actually we can do count value equals count dot get the value, and then 0 to initialize it, and then +1. And afterwards, what we can do is for every single value, yeah, that should be good. And then next thing we want to do is convert into the bucket. So let's see. Yeah, that makes sense. Okay, so like basically at the end of this, we'll have a hash map looking like, let's say like we have like 1. Well, 1 is happens 3 times because you could count it to that. Same thing with 2, it occurs twice, and then 3 only occurs once. So we'll have a hash map looking like this at the end. Next thing you want to do is begin putting that in the bucket. So after all this is done, for key and the value in count, what we want to do is put it into the bucket. So we'll do bucket at the count, which is the value. You want that to be equal to the key. So, well, you want to append that to the key. So we'll do this. So for key and value and count.values, we want to append that to it. You want to append the key, which is the value, well, like which is like the number, into there. So that brings us to our next stage, what we were talking about before. Final thing we have to do is for every single value in the bucket, we wanna actually we wanna go backwards. So we'll do for I in length of bucket -1, and then we want to stop at -1, and then we want it to go backward. And to do that in Python, you can do the -1 operator. What you can then do is pretty much just append that to a res array. So we'll have res equals this, and then we'll want to return that afterward. Basically what we can do is then pop in every single element we get. So actually, we'll also need another loop to loop through every single element within that as well. V in every single value there. What you're going to want to do is append that value. So res.append v only if k has not been reached yet. So we can have another variable over here. Okay, actually, yeah. So we'll have equals k, and then what you can do then, actually, we can just subtract k. Actually, no, we actually don't need a counter at all, because we can just check the length of the result one. So if res equals k, if the length is already equal to k elements, then you want to return res. Otherwise, you just want to append that value. So, okay, let's walk this through again. For everything in the bucket, we want to check to see for every single value if the length of it is equal to k. If it is, then we want to return it. Otherwise, we append it. So let's say like bucket is populated with a value like this. Like for example, with this original one, we'll have just like 6 different empty arrays, 5, 6, and we're gonna want to have 1, 2, 3 in here. So we'll have 1 happening 3 times, 2 over here, and then 3 once. So okay, that's another thing we actually have to watch out for. If okay, yeah, makes sense. Okay, so it'll loop through all the empty arrays, and since there's nothing in it, it'll just skip over them. None of this will happen. And once it reaches 1, it'll check to see, since for every single value in the bucket, you check if the length of res is equal to k. If it is, then you want to return that value. Otherwise, you just append. Basically, yeah, otherwise, you keep going through it. It'll keep falling back for every single one like that. Okay. So let me just go ahead and run this to check for any errors. Alright, okay. What if we added a 1 to it in order to make sure that you couldn't, well, because you're popping it into the bucket and you want to do the actual count, not including the 0 index, we can do that. Oh, okay, right. Oh, okay, this needs to be put before. Because you need to append it before you do the check, otherwise it won't be valid. Yeah. Okay, nice. So the time complexity of the solution is O of n, and the space complexity of this is also O of n, because at the worst case, you're storing all the values within one singular bucket. Yeah, some weird things you actually have to think about for the space complexity is you could be storing everything in one singular bucket. It could also all be spread out, but in the worst case, it's always going to be just the length of the array itself. Okay, well, thank you for watching.